Okay, welcome engineers. So the first thing you'll need to do is you'll need to take out your environmental engineering worksheet. So I'm going to break this down for you and show you how it goes. First of all, I need to discuss this map with you. So I color coded the map to let you know what all of these parts are. So first, clearly, like right here, we have our ocean. Okay, and so I traced outside of this in a dark blue, just to kind of allow myself to understand this is not a color map. It's just a sketch, and I want to know and understand the different parts of this map here. The second thing that I decided was to take another darker blue and to decide that this is showing the river. Notice I had to trace a little bit along the outside of the river here because it wasn't showing up if I just went on what was photocopied as black. Then you'll see here that this is a land barrier, which I did in brown. So this is all land. Everything here on this side of the land is not affected by flood, meaning river overflow due to rain, or by storm surge. Okay, because so there's nothing there. And how do I know? Well, down here, there's a key. And in the key for Beach Town, it says that when you see this diagonal line, that is the area that has been flooded by the ocean storm surge. So all of these areas here, okay, and I drew this little, I also took gray and I went along this line to understand that everything here is storm surge flooding. Everything here, here, all of that is storm surge flooding. Okay, and you can actually see, I'll use my pencil here, right there on this side of the river, nothing flooded as far as storm surge goes. Okay, but here you'll notice that yes, there is storm surge flooding here. Okay, you can see now the two different colors. When you have this just gray, right, just the gray shaded, the gray shaded is a little bit more a little harder to see. So watch. Flooded by the river overflow due to rain. That is this area in here. Notice that it is in the area where the river is. This is all gray. Guess what? This is both. And I'm not sure if you could see that. That's why I had to show you. Follow my pencil. It goes here, all the way across here, and down, and there. And you can clearly see this is just ocean storm surge, whereas this area is both. And this area is both. And this area is both. So it's something to think about when you are building and designing. And if you have a levee, it's going to go near the river. Okay, levees aren't going to go by the ocean because that's not their intention. I also noticed there are historic buildings. Historic meaning of value to history. And so I decided to use a highlighter and I highlighted several of the different buildings. This one's City Hall. Then we have this building up here was not affected by the flood of the ocean storm surge or the river overflow. So we're not going to really be concerned about things that haven't flooded in the past. But there are several other historic buildings, and I almost missed this one when I first looked at the map. So you might want to take a minute, pause the video, and if you feel like you need to color code this map to help yourself to understand where the land is. So this is all land if it's not water, right? And then this is all land if it's not water, and then this is ocean down on the bottom, and then river. So if you need to do that, by all means, go right ahead, okay? And then, so if you need some more time for that, you may pause the video. Okay, then you're gonna need this next worksheet is your environmental engineer. Now, I boxed this out in green, and I'm reminding myself that in blue, I highlighted storm surge because the environmental engineer puts wetlands, they plant wetlands right after the ocean, kind of on the beach. Like if you think about like dunes or sort of wetlands, though, in areas where there are hurricanes, the beachy areas are going to get specific types of plants that will slow down those big waves that come. And you can notice that there are 1, 2, 3, 4 of them that you will cut out, and you will decide, if you, as the environmental engineer, where you will place these on the map and what your budget's going to be. Do you need all 4 of them? You'll have to find out. Structural engineer, I think it's very important that you box that out in brown like we did the other day, and remind yourself, and I highlighted in blue to tell myself what type of water a structural engineer will be dealing with, and they will be dealing with all kinds of floods. So primarily ocean, but you're going to be putting buildings on stilts. Now, you have a pretty significant budget here as a structural engineer. You can't have any more than what is here as a structural engineer. Then you'll put on the different hat of being a levee engineer, and you'll box this out in gray. You'll remind yourself that they are the ones that protect overflowing rivers. So I underlined that in blue. You may want to as well. And this is for building levees. The levees are smaller because the river is a smaller body of water. They're $50,000 a piece. You'll decide where to place them on your map as the levee engineer and how many you might need to protect some of these buildings. And then finally, the last engineer that you'll play is the seawall engineer. And I underlined in blue that I will, as a seawall engineer, I would be protecting from storm surge by building seawalls. So remember, it's ocean, pretty much then sand, wetlands, and behind that, before we reach houses or historic buildings, then we would have seawalls built. These are very expensive. Why? The concrete, if you look at this, is $300,000 and this is $50,000, but you could tell that the size of the concrete wall would be greater. However, you only are allotted 4 of these. Would you use all 4? Where would you place all 4 of them? Maybe you wouldn't make one particular line. Maybe you'd put 2 together in one area and 2 together in another area. And you'll decide that as you go on. So notice yesterday when we highlighted the scissors, it was to remind yourself that you were going to cut out all of these pieces. So I would start with environmental engineer. I would just cut that line out, cut out your 4 pieces for environmental engineer, and then I'll walk you through the process here. So for environmental engineer, we boxed this out in green yesterday, and the one thing I want you to do is understand what your solution is. So you'll help Beachtown by planting wetlands. A wetland is a swampy area between the ocean and dry land. The plants in a wetland knock down the storm surge so the town doesn't flood. Wetlands protect against storm surge, but they don't protect against river flooding. So don't put these near the river, okay? It's going to do nothing for you as an engineer. So first, number 1, your solution. You'll cut out your paper wetlands. Okay, these are your 4. Step number 2, you'll figure out which historic buildings you can protect with wetlands. And in pencil, you'd circle the buildings. So we have, I'm just going to help you with this first one. We have one over here. And, oh boy, one here. We've got City Hall, and we have this building. This building, even though it was only partially flooded, and don't forget there's one right here that was flooded by both the storm surge and the river, the ocean and the river. So we've got 1, 2, 3, 4, 5, 6 buildings that we want to try to help out. But there's something interesting to note here, and it says, hint, wetlands only protect against storm surge. Good to know. Then you'll basically place your paper wetlands only to protect, again, the circled buildings, and you'll decide, where you would place these. And I wouldn't glue them as of yet, because you might just want to place them around and think about it, because then you're part of an engineering firm. You're only the environmental engineer. And so if you decide to put your wetland here, let's say, well, now the seawall engineer might not be able to fit in a seawall. We'll see. Get it? We'll see. Bad joke. All right. So you'll ask yourself then, for number 4, how many wetlands do you need to protect all the circle buildings, and write the number here. And you might not use up all 4 of them. You might decide to be budget friendly. We'll see. You'll decide what you think is more important. Then going to the structural engineering page. So once you get to structural engineering, it says, what's your solution? You'll help Beachtown by putting buildings on stilts. Each set of stilts lifts a building above flood waters. For this solution to work, you must put stilts under every historic building you need to protect. Stilts protect from both river flooding and storm surge. So the first thing you'll do is you will return to that page where you are a structural engineer. You will cut out all of these different buildings that are on stilts. This is not new construction. This is construction that's already a historic building, because those are the buildings that we are protecting. And you will decide which ones you're protecting. And then you'll figure out, you'll pencil them in, circle those buildings. I'm not going to do it for you this time. And then put your paper stilts on top of the buildings that you circled, okay? And then how many paper stilts do you think that you will need? And you'll write the number here. Now you get to play the part of the levee engineer. And when you are a levee engineer, you'll help Beachtown by building levees. A levee is a wall of earth or stone built between the river and the town. Levees protect against a flooding river, but don't protect against storm surge from the ocean. So think about that double trouble idea. So the levees, you'll go back to your cutting page and you'll look at your levee engineers, and you have a nice amount of them, and you'll decide where to place them in relation to the river, right? And then you can decide how many of those levees you will need to preserve the historic buildings that are near the river. Okay. And then finally, you have the job of seawall engineer. And so as the seawall engineer, you'll help Beachtown by building seawalls. A seawall is a strong concrete wall built to stand between the ocean and the town. It can stop storm surge, but won't protect against river flooding. So you'll go back to your cutting page, and you'll go down to seawall, and you'll notice you only have 4 of them to deal with, and those are pretty pricey, $30,000 a piece. And you'll decide where to put them. You'll put your paper seawalls on the map, and they will only protect the circle buildings, the buildings you've circled. And also you have to figure out like which historic buildings are going to be protected. And remember that seawall is about the ocean, the sea. And so it's what's waving forward, what's coming forward. And again, after the wetlands. Now you're not going to have the wetlands on this page, but you're still going to have an idea of where you're going to build the seawall, and then also how much it's going to cost. Once you've done all 4 of those and you're feeling really confident, you can go to this final page. And the final page is about a budget. What can Beachtown buy? So you should have a team or company name. So we are not doing this in groups. You're doing this individually. So you have a name for your engineering firm. I would call it like Spanos Engineers, if it were my firm. And then I don't know what their budget is. I'm going to leave that blank. And I'm going to tell you how to complete this worksheet. So now that you've done everything, you, as the seawall engineer, you used a certain number of seawalls. Each seawall cost $300,000. So you'll multiply the number of seawalls by $300,000 to get the final dollar amount to calculate the total cost of what the seawalls would be as the seawall engineer. It's basically a proposal, a budget, something that you are proposing to the town. I wonder if Beachtown can afford to have all 4 seawalls. Then, as the environmental engineer, look back at your work, at what you decided, and the number of wetlands that you decided to plant. Understanding that each wetland costs $200,000, you'll multiply the number of wetlands times 200,000, and then you'll come up with a final dollar amount for how much it will cost to plant these wetlands. Then you'll look back at your levee engineer page and you'll see how many levees did you decide to place. Knowing that each of them cost $50,000, you will multiply the number of levees times $50,000 to come up with a total dollar amount for that levee engineer budget line. Finally, the structural engineer, how many buildings will they put on stilts? You'll write that down, how many of them you decided to put on stilts, understanding that each of them costs $150,000, and then you'll get a final answer or budget value for this line item for the structural engineer, and you'll write that dollar amount here. If you need scrap paper to do this and you don't want to do this work right here, that's fine. If you would like to keep this as professional looking as possible, because all of these papers will be turned into your teacher, okay? And this will count as an engineering lab report grade, which is important for you to know. At that time, when you're done with all 4, then you're going to decide the total cost. Because yes, you've played the role of 4 different engineers. However, you're part of an engineering firm. And now when those 4 people come together with all of their different budgets, you will have a total cost as an engineering company to tell Beachtown how much it's going to cost. And then number 8 says, this is really important, if your total cost is bigger than Beachtown's budget, you need to figure out how to lower your costs. Write your cost saving ideas here. Now, we're having fun with this. But I want to say to you, before you get down to this, I want you to look at your final dollar amount and ask yourself, what if Beachtown said, well, this all looks fabulous, but our budget is only $1 million. Oh my goodness, no, we can't help you. I don't know, how are we going to cut the budget down? What if Beachtown said, our budget is only, I'm sorry, but our budget's only $2 million. Now you're going to look at your final total cost and say, well, we want to work for you. We want to help your town, but how are we going to get close to that dollar amount? And so you need to think about what you will dream up the budget to be. And I am going to ask you not to be excessive and say that they gave you, $100 billion, because that's not the point of this. The point of this is that you've now decided where to build all of these things that will help to save a town from a hurricane. And I'm pretty sure that you understand that towns do have budgets. And even if that town is prone to hurricanes, that it might be the kind of situation where you might be very under budget or very over budget. And so you're going to see just how much it would cost. If you used up as much as you could of the materials, that wouldn't be the budget. So I'm not going to give you a fixated budget. Classroom teachers, if you're interested in giving your students a classroom budget, you can. But I'd like for kids to see how much you think you can budget, and then how much you think that a town might really be willing to spend. And I bet we're going to come up with lots of different dollar amounts. And this is the best part about you having played all of the different engineers, being the seawall engineer, the environmental engineer, the levee engineer, and the structural engineer. I think you're going to really enjoy and see what it takes to be part of an engineering company and what it takes to try to save a town from a hurricane, which we know people work really hard to do, but may not be successful. So I hope I leave you with a really exciting engineering project ahead of you. Take your time. If you need to do some more of this, maybe at home and work on it there, that would be up to your teacher. So good luck and enjoy saving Beachtown and building not just a great budget, but building your company name and trying to save a town from a hurricane. Stay curious.